This is lesson 4.4 out of the Introduction to Algebra book. 4.4 begins on page 88, and lesson 4.4 is titled Quadrilaterals. Let's get that old word out there. Quadrilaterals on the coordinate plane. So as the name would suggest, quadrilaterals are four-sided figures. And so we are going to be graphing four-sided figures on coordinate planes and using our knowledge of how the quadrants of a coordinate plane works to complete figures. But the first thing that we have to do is a quick little warm-up here. So on our warm-up, it's going to be find the area and perimeter of each figure. All right, and number one is a figure that looks like this, and it has measurements of 5 centimeters and 5 centimeters. So you know what kind of figure that is, right? So perimeter and area. All right, and the second figure, number 2, is and it has measurements of 7 centimeters and 4 centimeters. All right, so find perimeter and area for those two figures as your warm-up. So I'm going to leave a little bit of space for the work. You need to write formulas, plug in known values, find your answers. Okay, so, oh, actually, and then we need our I can statement. Let's see, 1, 2, 3, yeah, that should be enough room. Okay, so in this lesson, we will be learning how to I can use properties of quadrilaterals to solve problems on a coordinate plane. Okay, that's what we'll be learning to do. This really is just kind of more practice at plotting points, and then also a refresher on the different types of quadrilaterals, polygons, and what their properties are. So you'll kind of get a real basics geometry refresher in this lesson as we work with the coordinate plane. So that means we need to go over some vocabulary. We have two notes, and the ones that I want you... Oops, how did I do this? Yeah, I put this one up there first, and then this one slid down, glued. Here we go, like that. Okay? All right, so let's do this one first. And I'm putting it all the way up in the farthest corner here. And then this one. and it's going straight down to the bottom alongside the other one. That'll give us room to write around these two. Okay, you see that? All right, that's how I placed them. All right, so vocabulary. We'll be talking about a variety of different shapes here. The definitions for what is a quadrilateral, a parallelogram, a rectangle, a rhombus, a square, and a trapezoid. Okay? Those are the ones we'll be talking about. All right, so simple note. I'm going to write right over here. If it has 4 sides, it is a quadrilateral. Okay, dot, dot, dot. Quad means 4. Okay, so that's what it says for quadrilateral is that it's a polygon with 4 sides. So in simple terms, it just means if it's a closed figure with 4 sides, it is a quadrilateral. All right, so then a parallelogram. Well, a parallelogram is any quadrilateral with both pairs of opposite sides parallel. So they can look different ways, but they've got to have those two things in common. So, for example, this is a parallelogram because this side is parallel to this side, and this side is parallel to this side. And we show it with these arrows, meaning the ones that are parallel, the ones that have the matching number of arrows, like this side and this side have just 1 arrow, that means those two are parallel. This side and this side have 2 arrows, that means those two are parallel. All right, that's how they show that in math. You'll see that coming up soon. So this would be a parallelogram because it has both pairs of the opposite sides parallel to each other, right? Well, so would also what we would call a rectangle. Okay, a rectangle is a parallelogram because this side is parallel to this side, its opposite, and this side is parallel to this side, its other set of opposites, right? So this rectangle is also a parallelogram. Okay, and if I were to draw one that was slanting, let's say this way, okay, this side is parallel to this side is parallel to this side, that also is a parallelogram. It matches the definition because its opposite sides are both parallel. All right, okay, so those are some examples. Now, let's see. Let's get parallelograms. These are all parallelograms down there. Okay? All right, so a rectangle, okay, a rectangle is any quadrilateral with all 4 angles equal in measure to 90 degrees. Okay? So what that means is, if we use this example here, my corners, my angles, and we show it with these little squares, are all 90 degrees. And if they are all 90 degrees, then it is a rectangle. It is also a parallelogram because both of its opposite sides are parallel. So we already know that a rectangle right now has 2 possible names. It could be 3, quadrilateral, a parallelogram, or a rectangle. All right? Okay, so let's talk about a rhombus then. So a rhombus is a shape that has It's any quadrilateral, meaning it must have four sides then, with all four sides equal in measure. Now, all four sides have to be the same length. But it's different from a square in that the angles don't have to be 90 degrees like they do in a square. All right, so all four sides same length. Could be like that, all four sides, and this little dash mark on the sides tells me that that all of those sides are the same length. Okay, it could be more slanted, and then sometimes that's why people think of rhombus. Sorry, that wasn't very good freehand, as a diamond. Okay, but as long as I've marked it that all of those sides are the same length, then it is a rhombus. Try to make that look a little bit better. Yeah, it's not easy to do freehand, which is why we have these marks. Whether it is an actual measurement or not, these marks say that I intend for all four of those sides to be represented as the same. So then a square has all the same sides. So a square is also a rhombus. Okay, so these are all examples of a rhombus. Okay, and then a square, I just want to make a note out here. We've kind of talked about a square. It has same sides, same angles. Same sides, same angles. So by definition then, a square can be a rectangle because a rectangle simply has to have all four corners 90 degrees, and a square has that. Okay, but a rectangle cannot be a square because a rectangle does not have to have all equal sides as well. I know it gets a little complicated, but we'll be thinking through those kind of things as we work on our lesson. All right. So then that leaves us with trapezoid. Trapezoid is any quadrilateral with only one pair. In fact, I'm going to underline that right there. Only one pair of parallel sides. All right. So it could be, it could look like this, where I have now this side and this side are parallel, but this side and this side are not parallel. So that means I've only got one pair of parallel lines. That makes it a trapezoid. Okay. Now it might also look like something really funky. What if I had this and this and this and way out here that? Okay. These two lines are parallel, but these two lines are not. So that then is a trapezoid. Sorry. All right. All right, so there's our examples there for all of our different shapes, and that takes in the first page of our notes. The second page, now we're going to learn how to use these shapes on a coordinate plane. All right? All right, so now on page 89, I have a little coordinate plane for you to glue in. And just go ahead and put it right up here in the upper left of your page, and then we'll work with our shapes. All right, so all right. Okay, and so here's what we're going to do with our coordinate plane we just put on that page there. It says 3 of the 4 vertices. What's a vertice? Vertices is plural of vertex and means corner. Okay. Corner or point sometimes. Okay. Corner of a square are at, and here are our ordered pairs, 1, 2, 4, 2, and 4, 5. Okay, there's our 3 ordered pairs. Okay, so we need to plot those 3 corners first, right? So the first one is at 1, 2. So that is 1 and 2. So that places it right here. Right? And the second one is at 4, 2. So I need to go all the way out to 4 and up 2. It's right here. Okay. And the third one is at 4, 5. So 4 and then all the way up to 5. Puts it right here. Okay. Those are the 3 vertices of a square. So what are the coordinates of the missing vertex? Okay, the missing corner of our square, the missing vertex. All right, so let's write that down here. If I can get that up there. There we go. All right, so the question is, what are the coordinates of the missing vertex? Asking what the coordinates are is the same thing as asking what's the ordered pair of the missing vertex. All right, so let's figure that out. We know that a square must have, in fact, I'm going to underline that. We're talking about a square. So the square must have 90-degree angles and all equal sides. So in order for my points to draw a square, I have to be equal distance from here to here and from here to here. All right, so I know that it would be 1, 2, 3. Right here is my missing vertex, and that missing vertex is at 1 and 5, right? 1 and 5. So let's write that down. My missing vertex is at 1 and 5. Missing vertex. I'm going to circle that in green. We wrote it in green. Okay. So we counted over 1 and went up 1, 2, 3, 4, 5. Yep, that's right. Straight across 1, 2, 3 to that one. 1, 2, 3 to that one. 1, 2, 3 to that one. So all of the sides are the same. And once you have those points in there, you can play a little connect the dots to show that you have a square. All right? Okay, so then let's write another problem down here. What is the area and perimeter of the square above. What is the area and perimeter of the square above? All right, well, area equals 3 units times 3 units. Oops, I forgot to write that times. The multiplication symbol times 3 units. And so that equals 3 times 3 is 9. So the area of that square that we drew on the coordinate plane up here, the area is 9 units. Okay. Perimeter equals, remember our formula for perimeter, perimeter equals 2 times 3 units plus 2 times 3 units, and well, I should have wrote units in there. So well, no, I didn't have to. Okay, so 2 times 3 of course is 6, plus 2 times 3 is 6, and so that equals 6 plus 6, not times. 6 plus 6 is 12. And so the perimeter is 12 units. Okay. So you'll have problems like that that'll ask you to figure out area and perimeter, and that's how you do it. Each side of each one of the tiny boxes in your coordinate plane is a unit, unless it tells you differently. Okay, so let's take a look at our practice problems. All right, here's the practice problems for lesson 4.4. On the first one, you're going to, this is where you get back to the first page of the notes and the rules for the various different kinds of shapes. It's going to ask you to determine if each statement is always true, sometimes true, or never true. All right, so on this one, it's got a square is a rectangle, a rhombus is a square, a rectangle is a parallelogram, a trapezoid is a quadrilateral, and you're going to answer for each one of these. Always true, sometimes true, never true. All right, and then problems number 2 and 3. Draw a coordinate plane out to plus and minus 6. Plot each ordered pair on the plane, and these are your ordered pairs. Name the shape with all the terms that apply, and that would include your parallelogram, your rectangle, your rhombus, your square, your trapezoid, all those possibilities that the shape that you wind up plotting could apply to. All right, so you want to pause here and draw these out, and then I'll come back and show you how they're done. Okay, so back up here to our A, B, C, and D. All right, a square is a rectangle. Is that true? Well, the definition of a square is that it has, well, let's see, that's the definition of a rectangle is that it has all 4 corners 90 degrees. Does a square have all 4 corners 90 degrees? Then it is always true. Okay. And then a rhombus is a square. Well, a rhombus, see, a square must have all equal sides, but a square has to have all 90-degree angles. A rhombus doesn't have to have 90-degree angles, but it could, so it's sometimes true that a rhombus is a square. Not necessarily, but sometimes true. Right? All right. A parallelogram has to have two, the opposite sides have to be parallel. So a rectangle has to have all 90-degree angles, which makes both of its opposite sides parallel. So a rectangle is always a parallelogram. Okay, a trapezoid is a quadrilateral. Well, to be a quadrilateral, all you have to be is to have 4 sides, and a trapezoid does have 4 sides. So that one is also always true. All right. Okay, so let's draw out our coordinate plane. They said, let's see, +6 to -6. Okay, so that would be 1, 2, 3, and 1, 2, 3. A little bit further for my arrow, a little bit further for my arrow. So in the center, try that, on the lines and in between, on the lines and in between. All right, so then we'll try 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, that looks pretty close. All right, it says draw a coordinate plane. We did that. Plot each ordered pair on the plane. All right, so I'd better have some labeling here. -3, -4, -5, -6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. And -1, -2, -3, -4, -5, -6. All right, so the first one is -3, 5. So on the x-axis, I'm going to go back to -3 and up to 5. There we go. The second one is -3, -1. So -3 and -1, that's down 1. Right in the center here. All right, the third one is 4, -1. So 1, 2, 3, 4, -1. And the fifth one is 4, 5. So 4 and up 5. So that's one more right here. All right. So if I connect these up, this one was out at -3 and this one was out at -3. So this is a, I will do it with this. So this is a, even though it might not have plotted straight up and down, we know that's straight up and down. All right. This one is at, the 4, -1 is at 4, and so is this one, also 4. Both of them are 4. So again, straight up and down. All right. And then these are, from the blue one to the green one, the y's are both on 5, so straight across 5. And on the orange one and the brown one, the y's were both on -1, so straight across to -1. So let's see. It looks to me like this distance is not as far as this distance. It's not the same. So I don't have a square, but they do appear to be what we would generally call a rectangle. But what are some other possible terms that we could use? Hold on a second, drop my pencil. Okay, other possible terms. All right, so let's look at it. A parallelogram. Well, a parallelogram has to have all 4 sides, or both opposite sides are parallel, and they are in a rectangle. So I'm going to circle that. Yes, that would apply. Is it a rectangle? Well, it simply has to have all corners, all vertices, 90 degrees, and they are. So it could be a rectangle. A rhombus, now a rhombus has to have all equal sides. It could be any degrees, but the sides have to be equal. This side is not equal to that side, so a rhombus it would not be. A square has to have all of its sides have to be the same length, and they are not. And a trapezoid would have to have only one pair of its lines parallel, but it has 2 pairs parallel, so it could not be a trapezoid. So parallelogram and rectangle are the 2 that would fit for this shape. Okay, so that's your practice problems for 4.4. Let's look at your worksheet real quick. In the First part here, like we did on the practice problems, look at your notes on the first page and figure out always true, sometimes true, or never true for each one of these. Really think them through, because sometimes it's not as obvious as you think. All right, on this one, you're going to, okay, so let's do some underlining here. You're going to graph each set of points on the point. So I'm going to underline. First, you're going to graph. Then you're going to connect the points, okay, in the order given. That means, in the order given means you'll start with this point and then connect to this point, connect to that point, connect to that point. In the order given. All right? Now, connect the last point to the first point. That means close your shape. All right? This is a nice, fun little connect the dots game. All right? Okay, now, name the shape with all the terms that apply. Parallelogram, rectangle, rhombus, square, and or trapezoid. So down here is where you'll name all the possible terms that the shape you plot here could possibly apply to it. All right. So then down at below at 8, 9, and 10, you've got find the area and perimeter of the figure in number 5. Find the area and perimeter of the figure in number 6. On 10, it says 3 of the 4 vertices, remember that means the corners, of a parallelogram are these. What are the coordinates of the missing vertex? So you might be able to do it without figuring out, without drawing it on a coordinate plane. And I'm not going to make you if you think you can figure it out. But it would probably be helpful to sketch something very simple and plot those and then figure out what's the missing vertex. Is it telling? Oh, and it's just telling. Oh, it is telling you that it's a parallelogram. So you know one thing about whatever you plot: it's got to have 2 pairs, opposite sides that are parallel. All right. So that is your worksheet. That leaves us with your exit ticket. Exit ticket. As you know, this is for extra practice. I don't show you how to do these or give you the answers to them. Okay, so that was lesson 4.4 out of the Introduction to Algebra book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.